Yes, sir.
Yes.
Okay. So as part of this curriculum, so we basically today in this today's demo class, I will walk you through the DevOps section. So what are the different, first I'll walk you through what is SDLC, what is software development lifecycle. Okay. So why exactly, the DevOps is needed? What exactly the reason for this DevOps evolution? We'll walk you through Agile and DevOps differences, different what of SDLC models. So later we'll discuss on the Linux operating system, because to continue the further sessions on the DevOps and AWS, we need the understanding of the Linux command. So we'll discuss basic Linux commands of how to create the function, how to create the shell scripts, what are the different basic Linux commands like ls, mkdir, rm. So there are bunch of commands like grep, std. So we'll discuss those things, and then we will discuss the version controlling system, which also called as source code management. So we majorly discuss the GitHub here, Git and GitHub, like where we create how to create the branches, how to create the repositories, how to pull the code, how to clone the code, how to commit the code changes, and how to push those changes back to the repositories. So we'll try to understand mostly overall of the Git and GitHub. And then as part of SDLC, we have a phase called build process. So we basically majorly discuss for the Java applications. All the examples, we will use it for the Java application. So for that process, we use Maven as a build tool for Java application. So we discuss what is the Maven lifecycle, introduction to Maven, how Maven helps in building the Java applications, what are all the different stages of Maven. After that, how the application is getting deployed to the Tomcat application server. We'll discuss what is Tomcat and how we deploy the Java applications into the Tomcat, and how we expose that applications on the browser. So we discuss those things, and then the heart of the DevOps we'll discuss which is CI/CD, which is continuous integration and continuous deployment, and sometimes it is called as continuous delivery. There are two contexts will be there. So we'll discuss what is CI/CD. We'll try to configure Jenkins. We'll configure the jobs. We'll set up the worker nodes or the Jenkins nodes, and we whatever the process that we are discussing, like fetching the code from the repositories, building it, all the CI/CD process, building deployment process, we'll try to automate them using the CI/CD process, and we do a lot of the steps over there. We'll create the pipelines using Groovy scripts and everything. And then as part of the CI/CD, we also have a security scanner, which is a SAST tool, which is a security static security assessment tool. Basically, this is to identify the code vulnerabilities within the source code. So as part of the CI/CD, before building a code, how this Sonar Cube is helping us to identify the code vulnerabilities that are there in the code. So this is for security part. Okay, Sonar Cube scan, and then we discuss about Nexus. So Nexus is a artifact repository where we store all of our build artifacts that are generated by the build process, build and compilation process. We discuss that with the example of Nexus, or maybe S3 bucket also. We can use the same thing. And for coming to the monitoring part, we use Prometheus and Grafana. Basically, this we will discuss while discussing the Kubernetes part, not here. But how we are monitoring the applications and servers and infrastructure, we use the Prometheus and Grafana part. And also we discuss the very much important tool and concept, which is a containerization, which is a Docker. So we'll discuss what is a virtualization, what is a containerization, why the Docker has evolved, what is the need for it, what are the advantages of Docker, and how we deploy the applications using Docker, and how we create the Docker images, what is Docker files, Docker volumes. We discuss all those things. And to the extent of this, we have a tool called Kubernetes, which is a container orchestration, which is a very high demand tool in the DevOps at the moment. So we'll see what is the Kubernetes architecture, how master nodes and worker nodes will communicate with each other, what are the different components of them, how we deploy the applications into Kubernetes, how to write the Kubernetes manifest files, how we can implement horizontal scaling. So this Kubernetes we will discuss by taking the example of Amazon EKS cluster, Elastic Kubernetes cluster. And then we'll discuss about Ansible, which is an automation tool, like how Ansible help us in doing the automation to bunch of servers, like hundreds of servers, how it help us. So we'll discuss different types of Ansible modules, Ansible roles, how to write the Ansible playbooks, how to configure the Ansible inventories, all those things we will discuss, and also Ansible Tower also. And for the incident management part, we discuss how the Jira will help us, how we create the sprints, how we create the epics, stories, which all of our tasks has to be tracked. So how Jira help us in doing them. So we'll discuss basics of the Jira, and we'll majorly come to the AWS part later. So in the AWS part, we'll discuss what are the VPCs, virtual private clouds, what are the subnets, security groups, internet gateways, NAT gateways, and what is EC2, Elastic Compute Cloud. Basically, it is a virtual machine. So how we will discuss how to launch them, how to create the EC2 servers from the existing AMIs, machine images, Amazon machine images, and how we create Elastic block storages. So we'll interact with the Amazon EC2 using AWS CLIs. So we'll do most of the stuff in the EC2, and also S3 buckets, which is a storage platform, and IAM for the authentication authorization in the AWS. How we create the users, groups, and user roles and policies. How it will help us in controlling the access between the different services and for the users. And we also discuss about AWS CloudTrail, which is a auditing tool, how the actions are being performed within the AWS, like who is doing what and when and how it was done. So those kind of auditing purpose we use CloudTrail. And CloudWatch alarms, because CloudWatch is a native solution for the monitoring in the AWS. So we'll discuss how to set the CloudWatch alarms and how we trigger different other events like SNS topics, the Lambda functions. We'll discuss those things. And then once we discuss all these cloud platforms, cloud services, we will see how Terraform is help us in doing this automation into this AWS cloud. Like we will write Terraform template, we will spin up bunch of EC2 servers, VPCs from scratch, and also EKS clusters, and how the statefile module statefile is going to be useful, and how we are locking that statefile. So we'll discuss a lot of those things. So this is about majorly on the curriculum part. So a lot of things we will discuss in this course of duration. So any questions on this course part before we dive into the introduction part of today's? Cool. Thanks. So yeah. So does anyone have any idea about the DevOps as of now? Just give some rough idea if anyone just take 1 minute. Just want to understand how aware you are of. No? Good. That's fine.
No, a little. It's just basically development and operation. You're basically doing it before. It was like different departments. In this, they actually basically combine both of them, development and operation, and just like under one umbrella. And that's pretty much it.
Nice. That's good to hear from you. Yeah, that's correct. Basically, DevOps will help us to bring the collaboration and communication between the development operations, right? So earlier we used to have development team and operations team. Now DevOps comes. You don't need to work in separate departments. We are a part of a single team. So both development and operations will be a part of a single team. That's why we call it as DevOps team. But before discussing about DevOps, first we have to understand what is a software development, because this DevOps has been evolved to basically make our software product to get delivered to the client in a most efficient and faster manner with less issues, less errors, less bugs. It improves the collaboration, it improves the automation, it improves the security. So, but before discussing the DevOps, what exactly is a software development is, right? So yeah, so software development is what? So if you are trying to develop any kind of application, any product, any mobile application or any desktop application or any web application, we have to go through certain phases in developing that application. We cannot simply write the code and do the stuff, right? So that has to be designed. We have to plan for that, right? And we have to start coding, and the code has to be tested, and then that tested code has to be deployed in various environments, right? From we have different types of environments: development, testing, staging, demo, performance test, production, like that. Because we cannot simply directly write the code and do the deployment into production, it has to go through certain phases. So that particular thing is called as software development lifecycle, right? Yes, so software development is nothing but it's a process of designing, coding and testing and deploying the software applications. The main goal in this software development process is to basically meet the client specific requirements, because client is giving some requirements saying, I need a banking application, or I need any insurance application to be developed within 1 year with all the types of components. That is what the requirement we got it from certain client, right? Now we have to design that how we can plan those. Let's say if the customer has given 1,000 requirements, how efficiently, how fastly we can deliver those 1,000 requirements to the customer. That is what deals by the software development lifecycle. So software development lifecycle, the main goal is to meet the customer requirements. Whatever the customer has put those tasks, the requirements, we have to properly plan them and design them and implement as part of the SDLC process. So here it is basically involves the collaboration. How it will have, because a single person or single team cannot do all these things. There are multiple teams will get involved. We have a development team, we have an architect team, we have a business analyst team, we have a sales team, we have an operations team, we have a multiple people, we have a database team. Multiple people will come together and make this software development successful, right? So that is what the software development will basically focuses on. So its main goal is to meet the customer requirements with the best possible way, and by enabling the collaboration between all the developers, testers, operations team, and other stuff to basically deliver the high quality software successfully deployed to the production environment. So there are multiple phases we have discussed, right? The first phase is the planning phase. So before starting anything, before starting any kind of activity, we have to plan it. What we have to plan? What is this particular scope of the project? What we are going to achieve? What are the different things that we are going to do as part of this project? Let's say 1,000 requirements. What are those 1,000 requirements? We'll get the things from the customer in the form of business requirement document. So let me just take a Microsoft dashboard. Yeah. So before starting anything, so we have a we have to develop some application called, let's say, abc.com. ABC is our customer. We have to develop this software like abc.com for the ABC client. Now this client will give the requirements to initially the sales team or marketing team. Like whenever this particular sales team from the software company, like we have this software company who is basically dealing with, you know, developing or giving the services to the clients. Okay, so this particular company has multiple teams. They have sales team, they have, product owners who is owning that particular product or project owners, and we have business analysts who are basically the key pillars of enhancing the requirements, who closely works with the customers and getting the requirements properly and discussing with them, with the developers, and getting our requirements satisfied. And we have architects who are basically designing the application, how this particular application has to be developed, right? So we have developers who are actually the one who are actually writing the code, and we have and we also have the testers. So once the developers has written the code, the testers will come to picture. They will test what is the code that is developed by the developers. So they will ensure the quality of the code, right? And we have an operations team who will work under the backend and helping other team members like developers, testers, business analysts, architects, who are basically providing the environment or the platform for that software application to successfully develop, test it, and deploy it and run. smoothly. So these are all the, this is a kind of a unsung heroes in the entire I would say the software development lifecycle, right? They all do this things in the backend, but their work is not that much properly recognized because that stuff is entirely, it's a black box for a lot of the people, right? All the infrastructure and everything. And and we have the database team. But of course, database team will also come under part of the operations team, who are basically maintaining the infrastructure. And we have a maintenance team or support team, I would say. So these are all the different types of the teams we will have in the any particular product. So first of all, whenever we got a requirement from the customer, the sales team approaches to the customer and say, and make a deal with them, saying that, okay, I want my application, this called as abc.com, to be developed within 1 year. So they will have the introduction with all the customers, managers, our product owners, our business analysts or architects will have the discussion, and they will give some requirements. They will give requirements in the form of, let me just type it out. So customer will give the requirements to the company in the form of BRD. This is the initial document, initial draft, which will be given by the customer. So it contains the business requirements document, which contains the high level requirements. Let's take an example of any banking application. Let's say, for example, there is a new bank that is getting established in maybe next upcoming years. They are trying to establish a new bank altogether, and they are trying to develop a website for them. So they need a accounts page in their website, right? They need a loans menu. They need a KYC menu. Like that, they are having so many menus, right? So many requirements they want to have on their application, right? So they will highlight all those things. I need the KYC form, I need the accounts tab, I need the what are those things. They will list out everything in this business requirements document. That is a high level requirement that will be given by the customer. Okay, in this case I just took the example of the banking. Like that, it is applicable for any type of domain. It could be insurance, it could be healthcare, it could be finance and everything. Okay, now this document, this business requirement document, once it is given by the customer, it will be analyzed by the product owners and the business analysts. So they will understand, and of course maybe with the architects also. So basically they will understand what are exactly are the requirements of the business for the customer. Then they will try to convert that with the business requirements documents into FRD, which is a functional requirements document, which will be understood by the developers. So once the business analysts discuss these requirements, let's say they have some 10 requirements in this. Okay, let's say 100 requirements. These are all high level requirements. High level requirements means not that much clear. We cannot understand. It is only the business level of understanding, because as a customer, as a client, they don't need to understand the underlying, the concepts, how they are going to be implemented, right? For example, how the accounts page is getting, created, and what are all the dependencies for those things. They don't know. So they just simply say, I need an account tab. But how that is going to be created, the functional specific things, they might not be aware. So that's why these high level requirements will be converted into the low level requirements. We call it as functional requirements document. So these 100 requirements will be divided into 1,000 requirements, right? With a detailed manner. So because this FRD is kind of a what you call source of truth for the developers to start developing the code. They use this FRD to write their logic. Okay, that's why they will convert those requirements into understandable and meaningful manners, meaningful requirements. So once that is done, once the developer started writing the code based on the FRD, then it will be handed over to the testing team. Now testing team also will start testing the code, but for them, for them to do the testing, FRD is not sufficient. They have to test it in multiple ways. That is what the testing is, right? Because when the developers are doing the testing, they will only do in terms of their unit testing. They will only do the testing for their functionality. They will not do all the things. So that's why this particular document will be converted into test strategy document. Test strategy document by the testers. The test strategy document contains furthermore low-level requirements. Furthermore low-level requirements with each and every scenario. So which means these 1,000 requirements will be split into 10,000 requirement, 10,000 scenarios. I'm calling it as 10,000 scenarios, which means now you are understanding the depth of the particular quality. This in order to make this 100 requirement to be successfully working, the developers are writing the code for 1,000 requirements, and testing team is basically doing for 10,000 scenarios, which means they are not leaving anything. They're trying to do every minute possible way. They don't want to take any chance of missing any scenario, so that the client will face those issue in the production. So that is the efficiency that the team has to follow while they are planning, while they are designing these documents. That's why these documentations are very much important in any given company when they are writing, when they are following the SDLC process. So that is what it is. Now this is how we will have the test strategy document. Now we'll come to this part again. Yeah, now we'll come to the part of planning phase. Okay, so this we have discussed here, the different types of teams and their work, how they will start their work. But initially the first phase will be the planning phase in this SDLC. Before starting and everything, first we have to plan it. So in the planning phase, we will discuss the scope of the project. Scope means we will discuss what are all the requirements that we are going to cover in this, and what are the requirements are not covering, and the time duration, and the what are the objectives, what are the goals as part of this particular planning. And then once we design, and also we will estimate the time, by how much, by when we have to complete this particular delivery. Okay, that will be discussed in the planning phase. Then after that, as I mentioned, the architect team will be involved in the design phase. So in the design phase, the product architectures, or product owners, project owners, or project managers, or business analysts will come together, or architects will come together and create the architecture diagram. See, architecture diagram is a kind of a blueprint. Like, for example, when you're developing or when you're building some house, when you're constructing some house or home, we will consult with the architect. Like, my house has to be like this, right? The area has to be like this, hall has to be like this. We will ask them to create a proper architecture or the blueprint that we will use it as a reference or a template to actually build our house. Similarly, when you are developing your application, we need to have a high-level architecture diagram. So by which the developers can understand, okay, these are the components that are communicating with each other. Between, like, front end has to communicate like this, database has to communicate like this. So to have the clear understanding or pictorial understanding, they have to prepare the architecture diagram in the design phase. And also the how the database has to be designed, application architecture, infra architecture, and also the database designs, database models. It depends on every aspect. Okay, like, is there any machine learning or AI has to be implemented? Like, everything we will discuss as part of this design phase, and they will create the high level documentations and high level what you call the architectures, right? And yeah, of course, in the planning phase and this design phase, this will be converted to this will be in the BRD. This has a FRD. Okay, we will get the things by getting the things from the BRD. They will define the scope, goals, and estimate, and that will be given to the architect team and development team, and they will create a FRD, and business analyst team, they will create FRD and create all the architecture diagrams and infra database models. And then next is the development phase. Once the design is started, now the developers has got the idea of what they are going to develop. Now, based on this FRD or based on these architecture diagrams, they will start developing the code. Okay, basically they'll start writing the code. Of course, in the design phase, they also choose the type of technology, what technology they are going to use, which means whether it is a Java based application or is a .NET based application or Python. So architecture will provide those information based on their experience, based on the project requirements, based on the domain. Like every domain having its own, chooses its own specific language. Like banking chooses certain type of language. Normal e-commerce users chooses certain type of programming languages. And what is the front end? Front end technologies like React, Angular, Node.js, those things. And also the databases. Oracle database, is it the MongoDB or PostgreSQL? They choose all the database, the technologies. Okay. And also the infra level technology also. What is the infrastructure technology that they have to, whether they have to go with the GitHub repositories, whether they have to go with the Jenkins, whether they have to go with the containerization using Docker and Kubernetes, all those things. What is the monitoring solution? So everything they will uh, design and come to some conclusion at this design phase. Then once that is done, developer starts writing the code, write code and develop the application. Start developing the application in their development environment. Okay, development environment. Because we will give a separate environment, separate server, separate the platform for the developers, so they can start developing without any dependency for other team members. And as the development is completed, the next stage is the testing stage. Okay, so in the testing stage, whatever the code that is developed or whatever the application that is developed by the developers in the development environment, we will give the similar environment to the testing team. We call it as testing environment, and we ask, or this testing team will use this testing environment to do the high level testing, in detail testing. We call it as functional testing or regression testing. So basically in this development, they will perform the unit testing. Developers also will perform the testing. That testing is called as unit testing. So unit testing is a concept. They will test only their functionality. They will not test further functionalities. So let's say we have multiple 10 developers. 10 developers have been given different requirements. So each developer will test their own functionality only. So they will not test other developer functionality. So that is unit testing. But in the testing environment, they will do functional testing, which means they will test every scenario, and they'll do a lot of testing here, like regression testing. We'll discuss these phases later. And we have integration testing, and we have performance testing, how the application is performing when the load is high, when the traffic is high, when the number of users are using the applications are high, how it is performing. Like that, they are having multiple types of testings. Okay, and also business UAT testing, user acceptance testing. Those kind of things we will do. Okay, yeah, that is as part of the testing phase. This is basically done by the QA team, quality and assurance team. Okay. So testing ensures the code work correctly through various types of testing. Those types of testing we have seen. Okay. Now we also have the deployment phase. Once the code is properly developed and tested, so we use this deployment phase to promote this code between the environment. So first we will do the deployment into development, and then from there we will do the deployment into QA. Once they have done all the types of testing, once everything is passed, then we do the deployment into production. Okay, deployment into production. Okay, so making the application available for use in the production environment, that is during the deployment phase. Once the production is working fine, then we have to start maintenance mode, which means application is developed, 1 year is completed, we developed all 1,000 requirements or 100 requirements given by the customer. Now our end goal is to basically start maintaining the application. This abc.com is ready now. Okay, now we have to maintain this, which means there are no major enhancements will be there. Okay, so we just monitor that, how the application is behaving, what is the CPU usage, what is the memory usage, is there any application locks are coming up, is the application is slow. Those kind of things we'll do as part of maintenance by using the monitoring solutions. So these are all the different phases of the SDLC. We have the planning phase, design phase, development phase, testing phase, deployment phase, and maintenance phase. So all these things we will use as part of the SDLC, software development lifecycle. So this is the initial thing that we have to understand before understanding anything on the DevOps later. So I think it is clear. So we just discussed what is software development and the key phases involved in software development, and what are the teams that are involved as part of the software development, and what are their roles. Any questions here till now? I just want to stop for a minute and ask any questions.
No, sir.
No.
Okay, thank you for confirmation. Okay, now let's move on to the next one, which is SDLC life cycle. We have discussed the SDLC, what you call that, phases or models. Sorry, the models. So you can see, I just try to display this in a diagrammatic the clear understanding manner. So what we have different stages of life cycle: stage 1, stage 2, what we are doing in the each stages, the planning and requirement analysis, what we are doing, stage 2, defining those requirements, which means basically converting that into functional requirement document, right? In the design phase, right? Um, yeah, here it is, HL is nothing but high level diagram, LL is nothing but low level diagram. So low level diagram is nothing but it is clear cut understanding of the project, whereas high level understanding is nothing but only the users, uh, the product owners, they can only able to understand. But low level diagrams can be understood by the technical teams, because they have all the technical components in the low level diagram. So they will define all those things. And also in the stage 1, in the planning phase, they also define the resource planning, like how many people, how many development team has to be required, how much cost is required, how many testers have to be required. So all those things they will plan it. The resource planning is also happening. And in development phase, they'll start developing, but when they're developing, they have to maintain some coding standards, the file naming conventions, and the branching strategies, the version control, the code reviewers, all those things, they will be part of the development phase. And testing phase, we'll discuss the manual testing, automation testing, and system testing, integration testing, functional testing, all those things will be there. And the deployment and maintenance, how this particular application is getting released to the production, we have to plan that release planning. Okay, and how this can be automated, deployment automation. So our major part is coming under the deployment and maintenance part as a DevOps engineer, because we have to provision the infrastructure, we have to provision, we do the deployments, set up the automation for that, and maintain using the monitoring solutions. Okay. So software development lifecycle, basically it is an approach in the software development. It has various stages involved in the development process. We have different models in the SDLC, okay, to make it to implement these phases. So we have waterfall model, which is the oldest model. We have an agile model, which is which is having a lot of benefits. We have a V model, spiral model, iterative model, RAD, rapid application model. There are so many models are there, but in this scope, we'll discuss the waterfall model, agile model, and then to the add-on, we discuss the DevOps. Okay, DevOps is not a SDLC model. Remember, DevOps is not a SDLC model. DevOps is a cultural shift. I'll discuss that top at the end of this particular session of what exactly the DevOps is. But yeah, the models are waterfall model, agile model, V model, spiral model, iterative model, and we have other models like RAD, those things. But for now, we'll discuss waterfall model. So each model has its own advantages and disadvantages. Okay, based on our requirement, we have to choose the best model. For example, if your application is legacy, which is a mission critical application, which means once you define the requirements, once the customer has defined the requirements, there is a high, there is no chance of for the customer to modify them, which means that the requirements are pretty much precise and clear. There is no chance for the customer to modify even after 1 year or 2 years, which means while they are defining the requirements itself, they are very much particular. Like for any mission critical applications, like defense applications, right? They kind of not change quickly. Of course, there are certain scenarios they will change quickly, but before discussing or before implementing anything, they do thorough analysis of how the application is going to get deployed or maintained. So for those kind of things, if the requirements are pretty much straightforward, pretty much clear and simpler to understand, there is no complex scenarios, which is very much easy to implement, then we go with the waterfall model. So basically in the waterfall model, what happens is, here each phase in the SDLC, planning, design, and development, testing, those phases will be executed one after the other, which means once the planning phase is started, and when the planning phase is in progress, other phases are not even working. They don't even work. There is no testing, there is no development and everything. Okay, once the planning phase is done, and they go to the design phase. And once the design phase is done, right, there is no way to go back to the planning phase again. It's always downward, like how water will flow towards down, right? There is no way for the water to go back up. So similarly, in the waterfall model also, it follows a sequential process, which means the project flows downwards like a waterfall through various phases, like requirements, design, and development. So which means each phase is distinct, which is not having any dependencies, which is not having any frequent changes. So the changes are difficult to incorporate once a phase is completed. So once you're done with the changes, there is no way for us to go back to the change, to go back to that phase. That's why we have to follow a proper planning, a thorough analysis before designing the requirements for the waterfall model. And it is best for simple projects, which means there are no complex requirements, very simpler to set up. Then you can go with this, which means the requirements are not getting changed frequently. The advantage is very simple and easy to understand. Each stage is defined with the proper requirements, the specific deliverables, right? And it works well for the fixed requirements. When the projects are having the fixed requirements, not dynamic requirements, we can use this waterfall model. So this is how the model look like: requirement analysis, and then the system design, and then the implementation, which is development, and then the testing, deployment, and maintenance. The only disadvantage is it is inflexible, right? It is very slowly adaptable changes. We cannot adapt the changes quickly, and no changes at all, no adaptability at all. For example, when the development is going on, and you want to do some change in the plan, design phase, you cannot do that because already development is in progress. Already design is completed. Whatever the design that is there, that is developed by the developers. So the design has to be changed. Again, the development has to be changed. So they are not flexible for that. So testing occurs only after the development, which means it could lead to costly fixes late in the process, right? Because testing team will not start the testing process until and unless the development has completed. So which is very much slower in terms of speed, right? So that's why it is not faster and not ideal for complex or evolving projects, right? Because there is no way for us to modify the requirements. So that's why we go with the agile model. So agile talks about the term agile talks about agility, right? So because of the lack of agility in the waterfall model, because of the lack of flexibility in the waterfall model, we introduced agile model. So in the agile model, it achieves the agility or the fastness by continuously, whatever the requirements that are there, it will break down those requirements into multiple chunks. Like if you have 1,000 requirements, 100 requirements, in the waterfall model, all those 100 requirements are planned once, developed once, tested once. There is no splitting. There is no dividing of those 100 requirements. But in agile model, those 100 requirements, let's say our customer has given the task, I want these 100 requirements to be completed by the end of the year. What we will do in the waterfall model, we will reach out to the customer after 1 year only. After 1 year, once everything is properly developed, tested, then only we will go to the customer and say, hey, I have completed all of your changes. I have developed all of your changes. Then customer might feel happy, might not feel happy. It depends on the efficiency of the development and testing. But in the agile model, we will not wait for 1 year. We will start developing, testing. We'll start first in the, okay, let's say we have 12 months in a year, right? So if we start the thing in the January, we will not do all 100 at once. We'll take first 10 requirements. Our goal for the January month is to deliver the 10 requirements to the customer by the end of the Jan. Okay, so all that 100 requirements, we will divide into multiple iterations, multiple sprints, okay, multiple loops, we call them as. So in each iteration, we will develop, test, and deploy few requirements. So let's, for example, 100 requirements, if you divide it by 12, it will be around 10 requirements per month on average. Okay, so first month we will develop, test, and deploy 10 requirements and give it to the customer. We give to the customer at the end of the January. Hey, I have developed your 10 requirements. Are you feel satisfied? Let me know. If not, I will work on doing the modifications again. So like that, we introduce the flexibility for the customer. then customer also will satisfied. Okay, I got my 10 requirements. I can, let's say out of 10 requirements, 8 requirements are good, but 2 requirements need some changes. They can propose those changes, and those 2 requirements can be worked parallelly in the next month. So like that, they continuously evolve their application. They continuously modify according to the customer requirements. So that's how the application becomes very much agile, very much flexible. Okay, so agile model is an iterative and flexible approach in the software development, which promotes a continuous improvement, because we are giving the product to the customer very much earlier, or in a phase-wise manner, first month, second month, like that. So they can have the collaboration, continuous collaboration. That's why mainly it focuses on delivering small, remember, the small, not large, all at once. We divide all of that large product into small chunks, small products, small iterations, and we deliver that particular small functionalities only, small requirements only. So it focuses on delivering small functional parts of the software iterations. We call them as sprints. Okay, so main thing is it is an iterative process, which means repetitive process, right? The work is divided into small manageable chunks. We call them as sprints. So what is sprint, right? So in the racing track, we have certain sprints. The same sprint is going to be repeated for continuous loops around 3 times, 4 times, 10 times, like that. Okay. That sprint duration in the agile methodology typically will be there for 1 week to 4 weeks. It depends on the company. Some companies choose 2-week sprint cycles. Some companies choose 4-week sprint cycles. In that sprint cycle, they will do all the planning, designing, developing, testing phase. Okay. Because of this agile methodology, we'll frequently deploy the, frequently release the product to the customer, which means first month we will deliver 10% of the product, second month 20%, next month 30%. Like that, we incrementally deliver the product at the end of each sprint. Okay, with each iteration, we are delivering a small product portion of the product, which is basically helping us in delivering the product, faster. And it emphasizes on the collaboration between all the developers, stakeholders, and users, and we get the customer feedback very much fast. Okay, for each sprint, we will ask the customer to provide at the end of the sprint, hey customer, I have delivered your 10 requirements in this sprint. Let me know how they look like. We got the feedback. If everything is good, then we can move on to the next requirement, next phase, next sprint. If not, something is not good, we can work that things also in parallel along with the next sprint. Next 10 requirements, we will go in parallel. And the customer is not satisfied or not having some issues with the existing 10 requirements, we can work those things also in parallel. Okay. So like that, we have parallel development, parallel enhancements, and also parallel bug fixes will go on. The advantages is it is flexible. Based on the customer feedback, we can make the changes, and frequent releases obviously improve the visibility and control, right? So we can have some easily understanding of what exactly is our milestones, how much percentage we have completed our project, where we are. We started in the month of Jan, and we, for example, now we are in the month of May. How much percentage of development and testing is completed? Those kind of things we can easily track. So which gives a motivation for everyone in the SDLC team to have the proper visibility and clarity to move forward, to make decisions. Okay, so you can see this. So in the agile, in the waterfall methodology, everything is sequential, one after the other. But in the agile, see, first 10 requirements will be planned, designed, developed, tested, and deployed, and launched at the end of the month. Again, next requirements will come up. Again, that is planned, designed, developed, tested, and deployed, and that will be launched. So which means each thing is iterating over each sprint. Okay, each requirements are iterating over each sprints. The main disadvantage is sometimes if the requirements are not well defined, the customer has not given the requirements, what will happen? In the first sprint, we will do some changes. In the next sprint, he come up and say, no, I don't want this. I want other changes. Then we will go and develop according. And suddenly next sprint he will come. No, I don't want this. I need some other changes. And also, if the scopes are not properly defined, which means if the customer is not given the clear scope, I need these changes, I don't want these changes. That kind of understanding, if we got, no problem. But if we don't have those kind of understanding of what needs to be developed and what not, develop. So that is lacking, that leads to some mess up. So that's why we have to properly plan these things also, and requires continuous collaboration. If the collaboration is missing, that would be a mess. If developers and testing teams are not communicating, or stakeholders are not communicating, it will be a problem. So for example, if the teams are very much bigger in sizes, okay, maintaining the collaboration is becoming difficult, right? So we have to have a lot of teams meetings with them. So it's some kind of challenge if the teams are very much large and complex and the distributed teams. But yeah, we can have the alternatives also for that. And it can be difficult to predict the final product in early stages, obviously, right? Because we are just at the starting phase. We just developed 10% of the product. We cannot predict how this entire final product is going to be. Okay, so I mean, these are not kind of a exact disadvantages, but we can consider them as some kind of disadvantage. But this is how we can implement. Now, to overcome, okay, now the main problem with this agile is it focuses on the agility, which means the speed, but it does not focuses on the stability. There are two things I'm trying to iterate again. I'm talking about agility and the stability. So agile focuses the fastness, right? Which is the agility. I want my application to get developed as fast as possible. But it's not focused on stability, which means it's not ensuring whether that product is stable or not, which means it is behaving properly for all the scenarios, for all the security scenarios, for all the performance scenarios, for all the functional scenarios or not. It is not ensuring. Okay. The reason is there is no, if the teams are bigger, it's not enforcing that continuous collaboration between the team members. And of course, in this process, both the development and operations team will work, in silos. We call it as silos, which means they are working independently, which means whatever the development that is being done by the development team is not aware by the operations team. They don't know what this development team is doing. They don't know. And similarly, development team doesn't know what operations team is doing. So that's why that stability issues is always happening, because of the lack of communication, lack of collaboration, lack of feedback, lack of that lack, I would say, lack of culture in the uh, process. So to overcome that particular thing, we have introduced DevOps. Okay, so Agile and DevOps are two methodologies that emphasizes collaborations and automation fast delivery. Agile focuses on software development. Its main thing is development. It primarily deals with the iterations, customer collaborations, and rapid delivery. This is what we have to focus, rapid delivery. It works in cycles, sprints, provide frequent releases with feedback loops. But DevOps focuses on entire software development cycle. So Agile is not caring about operation aspects. It simply focuses on development. I want my code to be developed. That's it. But it will not work like that, right? Because operations also has to follow certain practices, or development also has to aware of the things that are managed by the operations. They cannot simply say, hey, my code is working fine in my local, it's your responsibility to test it and make it work to the production. No, that's not how it's going to work. Which means there is no proper ownership in the agile, right? So that's why I'm saying the development and operations team will work in silos. Okay, to overcome those, because I would not say the disadvantage, that is the culture of agile. Agile simply focuses on development. They doesn't care about the other related testing and operation. They doesn't care about that. That's why the stability is lacking. That's why in the agile the stability is lacking. The main reason is they simply focus on the development, not the other aspects, right? Only development. I want my code to be developed fast. That's it. Whether it is working properly or not, they don't care. I mean, in the later phases, they just test it in their local environment, in the development environment. If it is working, they'll try to make it to the production as soon as possible. But as part of that, they're not focusing on the stability. They're not ensuring whether the operations team or testing team is properly maintaining the, practice, properly following all the communication that is given by the development team or not. They are not, ensuring that. That's the reason it is lacking the stability. So avoid that. So DevOps basically focuses on the entire development lifecycle, not just the development, not just the development phase, entire development lifecycle, right from the planning to the maintenance, planning, design, testing, and everything, including operations and deployment. That is what the main thing you have to understand as part of DevOps. That's why Ops came here. Otherwise, we simply called as dev, right? Why Ops came? Why we are adding the new person called Ops and adding to the adjacent of dev, because they are not kind of brothers earlier. They are not of same persons earlier. Now you want to keep them both. We are combining both. Now you are a part of same team. Don't you know clash yourself. It's your responsibility as a DevOps. You're not called as a development. You're not called as operations team. You are called as a DevOps team. Please ensure agility and stability. That is what the culture it is enforcing the team in the SDLC to follow. Right. So it emphasizes completely on the continuity. If your code is not working, operations team has to somehow make it automated so that you have to get automatic notification. There should not be any delay. There should not be any gaps, which means this entire SDLC has to be continuous by using the automation. Okay. Whenever they start writing the code, that has to be immediately tested, built, tested, deployed, and get the notification to the respective stakeholders. That is what the continuity means. Okay. So everyone in the team has to follow DevOps culture. So here it emphasizes DevOps emphasizes on automation and CI/CD, which is continuous integration, continuous delivery, which is nothing but as and when the developer is writing the code changes, it is immediately has to be built, tested, and deployed and notified with proper monitoring. That is what the CI/CD. Okay. The main thing is it enforces a collaboration between the development operations team. Right. Earlier the collaboration is missing between the development operations team. Okay, so if we talk about the differences, Agile primarily about iterative software development, right? But while DevOps extends Agile principles, so it is not a new thing. It is simply extending the existing Agile principles into operations and deployment phases also. Okay, so DevOps is just a extension of Agile with the focus on operations and development phases also. So Agile handles all the planning, designing, and development stages, whereas DevOps handles automation, monitoring, and continuous deployment after development. That is what the DevOps is. Okay, it adds an extra layer of automation and collaboration between the developers and the operation that Agile does not directly address, because that Agile is not focusing on the automation. It's not focusing on the collaboration between the development operations. So that is the main differences between Agile and DevOps. So if you see the difference diagram, right? So in this earlier, they only focuses on planning, design, develop, testing, deploy. Now they're not focusing on operations aspects. But if you can see, this is a continuous loop. Infinite symbol is there. Just a second, 1 second. Yeah, sorry, there was some disturbance. Okay, so that's how DevOps is focusing on the continuity. That's why the symbol of the DevOps, you can see it is an infinite symbol, right? So where everything is looped, there is no break between development operations. That's how it focuses on the um, continuity and collaboration. So how this DevOps culture is basically followed by using the various tools, like we have right from design phase, development phase, till production maintenance phase. everything is used by the different tools. So in the version control, in the development phase, we use Git, GitHub, GitLab, Bitbucket, and CI/CD, Jenkins, GitLab, CircleSafe. There are so many things. For container orchestration, we use Docker and Kubernetes. Configuration management, we use Ansible. I mean, not all of things. Any one tool is enough in each every stage. For example, the version control, we can choose any of these things, GitHub or GitLab or Bitbucket, any of these things. In CI/CD also, we can choose any of these things, Jenkins or GitLab CI or Azure DevOps, whatever it is. So in the communication collaboration, we use Slack, Teams, and everything. So these are all the different technology stack of the DevOps, right? Here it is not included any cloud. Of course, the cloud also will come up. All these things, tools are also part of the cloud. Okay. And the main roles and responsibility of DevOps is they develop, implement, and maintain CI/CD pipelines. They are the one who write the automation of how the code has to be deployed, built, tested, and deployed to various environments. Once the developer has completed the code change, the next responsibility is the DevOps team responsibility, which means, of course, it's part of DevOps team. The even developer also part of DevOps team. So the next stage is it has once the code written by the developer, then that code has to be properly built, tested, deployed to various environments by using the CI/CD process. So for that to implement, they will write the pipeline codes. That is one responsibility of the developer, the DevOps engineers. And they automate the infrastructure provisioning because DevOps mainly focuses on the automation, right? So everything they try to automate. They don't try to do anything manual. Okay, that's how they improve the implement the continuity between the among the team members. So they automate the provisioning of servers provisioning, storage provisioning, network provisioning, everything they automated, and they collaborate with developers, operations to streamline the deployment processes, and all the monitoring once the application is deployed, how they are getting, how they are working, what is the CPU usage, memory usage. If they check all the logs, they will integrate with them and troubleshoot any production issues. Okay, for example, once we deploy the code into production environment, somehow the application is not coming up. It is behaving very slowly. The primary responsibility it has to be by the DevOps engineers. They have to go and check what is the issue. Based on that, once they do the troubleshooting, once they did the initial understanding, they will try to collaborate with if it is a code issue, they will go and check with the developers. If it is a configuration issue, they will fix that in the infrastructure, like that. So that is DevOps engineer responsibility. I mean, so I mean to say DevOps is having so many roles in this. Everyone is part of DevOps. Developer, system administrator, QA is part of the DevOps only. But we have a separate role called DevOps engineer also. Okay, who will specifically do all these things, maintaining it, pipelines and everything. But developers are also part of this particular DevOps team only. So which means don't get confused. DevOps engineer is the only one who is part of DevOps team. No, everyone is part of DevOps team, but we assign some hat for the one particular person. You go and do the DevOps engineering activities like set up the pipeline, do the automation, infrastructure provisioning, do the troubleshooting, do the monitoring, those kind of things. And developers, they basically write the code based on the requirements, closely work with the operations team, and collaborate on the design that is developed given by the design team or architect team. And system administrator, they manage the infrastructure like in a manual way. I mean, if any issues happens in the infrastructure, they go and troubleshoot that in the server level, system administration like Linux, and they patch the servers, they provision the servers. Any system updates that are coming up, they will manage them. And QA, we discussed about this. They'll try to automate the testing as per the CI/CD pipeline, so that this ensure that software meets the quality standards before the deployment into production, and also conduct the performance testing, load testing, and release manager responsibilities basically ensure that particular code has to be properly deployed in various environments in a timely and phase-wise manner. Like for example, if the development is started for the sprint 1 at the month of starting month of January, the release manager engineer responsibility is basically to plan it for the production at the end of the month. They are the ones who will release calendar for the application. When the application is have to go into QA environment, staging environment, and production, they will design that. Basically, they will collaborate with the development, testing, and operations team for those application release rollouts. they conduct all the rollback procedure. For example, what somehow the version is deployed, but it's not working fine. They should have the rollback plan. You should immediately go to the previous version. So they ensure that rollback procedures monitoring during release process. And operation engineer responsibility, they will maintain the operation infrastructure with the high availability. They'll ensure that, I mean, it's a maintenance part, I mean to say. Once the application is deployed, they ensure that application is properly working fine with the high availability. It is always available and always scalable. So they kind of do all those things. So that is what about the DevOps is about. We discussed what is SDLC, what is software development and SDLC, and what is agile methodology, waterfall methodology, and the reason for agile methodology use, reason for DevOps, and what are the tools that are there as part of DevOps. We discussed all those things. So yeah, so this is about the introduction of DevOps. So mostly in the next class, if everyone is okay, we'll start from the first tool, which is GitHub, right? Which is a version control system. That is what the first stage. We will discuss how Git works and everything. We'll discuss those things. Yeah. So let me know if you have any questions.
Hi. Actually, I have a quick question. I'm so sorry. I was in some part. I was a little lost. I did try to like understand, but can you like tell me like very briefly what like as a DevOps engineer what we exactly be doing? Just like
Yeah.
very like brief. I'm so sorry. I was
No problem.
actually
No problem. I'm happy to
lost a little bit.
reiterate. No issues. See,
I
again,
I
thanks.
didn't want to disturb you like while you were going through. So that's why.
Yeah, thanks for that. It's always better to have the question and answer session at the end of the session so that we can easily
Thank you.
complete the things that we're talking about. Okay, I just want to reiterate once. So DevOps is nothing but it is a culture. It is a methodology. It is not a technology. It is not a tool. It is not a software. It is a culture or the mindset, I would say, the mindset that everyone in the software development lifecycle team has to follow. It could be by the developers, it could be the operations, it could be by the testers, architects, database teams. Everyone has to have this DevOps mentality or methodology, which basically focuses on the collaboration among those people, which reduces the friction between those people, saying that everyone saying that it's our team. Like there is no silos, there is no difference between the development operations. Earlier, what happens before DevOps, we basically separate the teams. When we separate the teams, the mindset itself will get separated, right? Just try to understand that. So when you separate the teams, like you are development team, you are operations team, you are testing team, which means what? We are splitting the responsibilities and which eventually splitting the ownership also, which means development team is not caring about what operations team is doing. And operations team is also not caring about what development team is doing. What is the main reason? What is the main issue because of that? If something is working in development environment, developer will say, hey, the code is working fine in my environment. I don't have any issues with me. Just go and take care of yourselves. That kind of things, this discussion will be made, given or communicated between the development operations. Then because operations teams is not at all sure what development team is doing. So there is no clue about operations teams. They simply said whatever the code that is given by you, I deployed. So that kind of silos, that kind of communication lacking is there because of the lack of culture, lack of mindset, lack of methodology, lack of a uniform methodology, lack of continuity is not there. Okay, that's the reason. So DevOps will basically focuses on enforcing the communication and the collaboration among all these teams, which will make our application to have the agility and also stability. Because in the agile methodology, it is simply focuses on the development aspect, not on the operations aspect, because they always try to develop the code and give it to the customer, but how the operations works, they are least bothered about. So that's why DevOps is reducing that gap by combining both development and operations into one umbrella, right? So now in this DevOps, their main focus is to implement automation, which means whenever the developer has completed the code changes, it is the DevOps team responsibility to have that code to properly build, tested, deployed all the way to the production. It's everyone's responsibility with continuity in the loop. If something is breaking in the between, everyone should get notified so that everyone is having idea what is going on in the backend. That is what it is enforcing using the DevOps uh, culture, DevOps methodology. So for that to implement, for that automation to implement, DevOps uses DevOps team, DevOps culture to have that implementation. They are using certain tools, multiple tools across each and every stage in the SDLC. So they use GitHub to maintain the version control, to maintain the code. They use Jenkins. So Jenkins is the heart of the DevOps because this is where everything is getting integrated. Development is getting integrated, testing is getting integrated. The continuity is happening in the CI/CD phase. That's why we call CI/CD as a part of the DevOps. I think that helps.
Yes, it does. Thank you so much. Thanks, Raj.
Thank you.
And like we we do I know need to know like some languages in order to move forward, or it just like Bash or some
Yes, it's just
Python
a
works?
bash. Bash scripting would be enough. Python is
Okay.
good to know. But as a bare minimum, we need to have the understanding of the Linux operating system, and we need to know bash scripting,
Okay.
considering that you are working on the Linux environment. There are certain, projects that they are focusing completely on the Windows operating system. They don't use any, Linux operating system. For example, in the case of Microsoft projects, .NET projects, their application is entirely being developed in the Windows platforms. For those things, we need to know the PowerShell scripting, Windows administration. That is a different aspect. But majority of the companies are, products are being developed under the Linux platforms. Okay. For that to know, we need to have an understanding of Linux operating systems and the Bash scripting. That is only we need. And Python also, it's better to know because see, DevOps is a vast area. So you try to understand how to do. There is no specific boundary for the DevOps. Of course, the boundary is there. It is simply a CI/CD process, but we can always extend that boundary to any possibility. We can extend to even AI/ML also. We can bring machine learning also into this DevOps and called as machine learning operations. And we also integrate this DevOps with the data engineering skills. So the scope is very vast. So my suggestion is once you gain some knowledge in the DevOps, do not restrict yourself to be in this DevOps zone only. Try to enhance your limits. Try to be in the data engineer position with the DevOps skills because data engineer knows has to follow this DevOps skills, and even the testing team also. Testing team also has to know this DevOps process. They have to understand how to integrate their testing with the DevOps process. Similarly for the machine learning, AI. So always try to increase that. So for your question, of course, at the moment it's not required. Programming languages are not required. Java, it's not required. But in future, because the teams are evaluating like anything. So currently at the moment DevOps is kind of is having in the high demand phase, right? But after AI/ML is being implemented by every company in the market, every company, then we have to know those things also. So for that we have to know Java, Python, majorly Python. Python is very much needed for all the in almost all use cases for data engineering, for DevOps, for data science, everything. So my suggestion is for now, let's go with these DevOps skills. After a while, maybe after you gain 2 to 3 years of experience, then you try to, have the programming languages skills also in your bucket.
Got it. Perfect. Thank you so much. I appreciate that. Thanks a lot.
Thank you. Cool. Any more questions?
No, I'm good.
Okay, cool then. Yeah, Himaja.
No, I have the same question like that. should know about the scripting programming language.
Yeah, not required. Program language is not required. Just scripting knowledge should be there. Shell scripting should
Linux
be enough.
is a programming language.
Linux is an operating system. Linux is an
Oh,
operating system on top of which we will write the automation scripts using shell scripts or bash scripts we call it as. Yeah,
bash. Okay.
yeah. So it's a
It is
simple.
hard to learn like bash
It is
scripts.
very easy to learn. If you're very
Oh,
easy to learn, if you are basically interested on it. Okay, it's not like it's not similar to program because programming is having so many concepts, right?
yes.
But shell scripting is basically writing some story. Scripting is writing some story like in a line by line manner. So it's not very difficult. It's very easy. All you
Okay.
need to know the commands. That's it.
Bash
Linux command.
scripts we don't need line by line coding. Just
Sorry, what? Yes, yeah, that scripting. I mean, into the scripting. It could be bash scripting.
bash scripting we don't need entire coding, right? Like
Exactly. See, I'm just trying to understand the difference between scripting and programming. Okay, so both are coding. Both we are writing the code for both in scripting and programming. We call it as coding only. But for scripting, it is a line by line execution. It follows the instructions that are given within the uh, code. Whereas programming, it is a modular approach. It is a procedure oriented approach. Okay, it call functions, it call libraries, it call packages. It does a lot of things in the backend, but it's very kind of complex to understand initially. I mean to say, but scripting is not like that. It is just executing the lines one by one. There is no what you call the sophisticated syntax is not required for the scripting. It's a English language, but with the commands. We just need to know the commands within the operating system. That's it. We can write the scripting.
okay, got it.
Yeah.
And agile and DevOps are different.
As I mentioned, right, DevOps is an extension to Agile.
Okay, yeah.
So Agile, there is no DevOps without Agile.
Okay, got
So
it.
Agile focuses on the agility, the speed of the product delivery, whereas DevOps focuses on the stability also. Along with agility, it adds the stability also.
Okay, got it.
Yeah.
And after the course, you will say any jobs like.
Yeah, that we can discuss later. But yeah, for now, we'll focus on the course completion part. Of course, we'll help on that, job, finding also, interview
Okay.
preparations and those things also. Yeah.
How many days of course?
It will be maximum from 45 days to 60 days in between. It can be
Oh,
completed within 2 months. Yeah.
and Saturday, Sunday, including Saturday, Sundays.
Yes, most probably Saturday, not Sunday. But I'll try to
Oh,
include. If you're comfortable, I'm not saying it is mandatory. If everyone is comfortable, I'm okay to give on weekends also because I'm okay to complete the what you call the syllabus as soon as possible.
yeah, okay, Nash. Thanks.
And for everyone, I just want to understand what is your availability time. Are you available in the morning or evening?
Evening.
Okay, everyone, right?
In in my time in the US, it's about morning. Early morning is fine with me.
Cool.
Yeah.
I think it's 2 hours or hour and a half ahead of your time, Indian
Mm-hmm.
Central.
Okay.
Sure.
Yeah. So basically, I'm
Not
available
exactly
in the
sure. I think there's a, like probably 2 or 3 hour difference between
same.
our time
Will
because
same
I'm in
time works?
Chicago Central Time.
Okay. Will same time works from today we started about 6 p.m. IST, right? Will same time works? 6 p.m. to 7 p.m. IST.
Yeah, it works for me.
Cool then.
Yeah, it works fine, but sometimes I do have like to be at work early, and
Mhm.
I'll just let you know if there is anything comes up.
No problem. You can always watch the recordings that is available. If something is missing, but if you have any questions, you can always ask the questions at the end of the session. I always help you.
Oh,
And most
perfect.
of the
I
things
appreciate it.
I'll
Thanks.
try to make you do the things when I'm giving the hands-on, right? And I'm telling about the concepts like writing shell script for installations or writing some Jenkins files. whatever the configuration that we are doing, I will make you to do that. So please be volunteer for that, because everything if I tell everything on my own, um, you might miss the, what you call that, the focus sometimes, right? If everything I'm doing, you cannot focus that much lively. So that's why I insist the candidates to volunteer for the interactive sessions while I'm installing something or configuring something. So I want you to do the things. I'll ask you to share the screen. So I'll instruct you to follow the steps so that you will have the hands-on in the class itself. So please be volunteer for that, and please be updated every day on the classes, so that next time, instead of the same person is volunteering, I'll ask other person to volunteer so that we can do in a shift-wise manner. I think you are getting my point, right?
Yes, yes, I got your point. I actually previously I spoke to Dia and took the solutions architect course through her. So it was actually, most of it was like, beginning was theory, but after later on, like I learned to build like EC2 instances and S3 buckets. Went all the way to like, very basic of EKS with Docker and Kubernetes. It was very very little though, but rest of the stuff I was actually pretty good. I did get to deploy the website like 3-4 times, so it was actually a
Nice.
decent practice, like hands-on, other than the theory.
That's good to hear. Yeah.
So hopefully it
Yeah.
will be also a good journey and excellent experience with you as well.
Absolutely. I'm happy to share my knowledge, whatever I have gained, to the best possible. Yeah. So let me know for any questions. Please always ask the questions at the end of the sessions. Yeah, we can discuss more.
You will teach us Bash, right? You will start with Linux and teach us Bash scripting.
See, I'll start with the Git first. GitHub.
Okay.
Once
Okay.
that is
Right.
completed, I'll go with the Bash. I mean Linux and Bash. I'll just give have some basic commands on the Linux, just to have the gist of the habituated to the Linux environment. Because as and when I'm progressing in the further sessions, I'll give more Linux things on, because everything is, we'll do it on the Linux only. So
Okay.
so eventually we'll learn a lot of things. So it's not like
Okay.
a separate session for Linux and Bash. It's getting
Okay.
evaluated as our course is getting progress.
No, I just wanted to know, because I was like thinking about, I did took some videos from YouTube or like other
Mm.
sources, but then like, when you're it's a different scenario when you're in a like, instructor led class. So I can ask the questions while like, for example, if I have some assignment to sharpen my bash skill, right?
Absolutely.
In
So,
those
yeah.
videos, I cannot. Like in this way, I can definitely ask you, like,
See, majority of the things that we are working in the Linux environment, right? So we cannot simply use Linux without using of any of these tools. As a DevOps engineer, we need to know how to install Tomcat. We need to how to install, set up the Kubernetes, how to write the, when we are working with the Kubernetes platforms, when we're working with Docker things, we need to know Linux basics commands. So as part of those topics, I will give the instructions on. I will give the classes on the Linux things also parallelly, and I'll teach you how to write the shell scripts for those things also. Like once you written the Kubernetes manifest files or Docker files, how do you automate them using the Bash scripting? And eventually, I'll come up with some use cases, like how do you rotate the logs, how do you create multiple users at once. So those kind of things, how to check the system memory usage and alert whenever it goes beyond 80%. Those kind of things will discuss during the progression of the course. Okay, all right.
yeah, thanks a lot. Thank you.
Thank you.